Good morning, class. This is Stats 300, or what's left of it, I should say. This is Monday, I don't even know what day it is anymore, March 23rd. It's around noon. And just want to say I hope everybody's safe and maybe staying indoors away from lots of other people. We will continue to try to forge ahead with our topics. I realize this is not the best format for people to learn in, but this is the situation where we're at. I apologize for not getting videos to you on a timely basis. There's a couple of reasons for that. One is I'm just not that tech savvy. Another is that I couldn't quite determine the correct or the best format to give you the information, whether it was webcams, document cameras, Zoom. I think many of your other instructors are using Zoom. I've tried it, but the quality of the video is quite poor. So what I'm doing is taking my cell phone and trying to just record videos, then hopefully that should be sufficient. I have a whiteboard at home. I'm sure everybody has a whiteboard at home, right? And what I thought I'd do is try to give a description of where we left off, which is in chapter 6-3, and it's called Sampling Distributions. And one way to illustrate what that means is if you look at the whiteboard here behind me, I'll try to center it a little bit better. I've got a very crudely drawn array or box. And if you can see it up at the very top, it says population of numbers. And suppose you have a population of numbers which only has three values, 3, 6, and 12. What I'm going to do is fill up this chart based upon the items that you see. Now, what I want to do is choose all possible pairs of size 2 from that population, allowing for replacement. So what that means is, and I can show you real quickly from the counting principle. So in the first position, I can have any one of the three numbers, 3, 6, or 12. If I'm allowed to repeat, I can have any one of the other three numbers. So if I multiply those together, that means there are 9 possible pairs that I can have with replacement. So what I want to do is try to fill up this chart based upon this. So again, let me see if I can do this. Trying to figure out the best way for me to stand. So if you look here at the first one, suppose I have a pair 3 and 3. Again, with replacement, which means I'm allowed to repeat numbers. Suppose the numbers are perhaps 3 and 6. And let's get rid of that n. Now, the order matters in this case. So what I'm going to do is put the value 6, 3 as well. That's another possible pair. Let's put the numbers 3 and 12. And then reverse it to be 12 and 3. Let's assume both numbers were 6s, so 6 and 6. Okay. Now if I reverse 6 and 6, it's still the same value, 6 and 6. So I don't have to repeat that one. 6 and 12. And I've got 12 and 6. And there's one final pair of values that I could possibly have, and that's 12, 12. Okay. So those are all possible pairs of size 2 that I can form from a population of numbers which are 3, 6, and 12. The next column is x bar, and all that means is find the average of the two numbers that you see here. So if you have 3 and 3, and you add them up and divide by 2, you'll just get 3.0. If you add 3 and 6, you get 9 divided by 2 is 4.5. Again, So what we're doing is taking x1 plus x2 and dividing that by 2. Now 6 and 3 and 3 and 6 are the same number, so this should also be 4.5. 3 and 12 is 15. Divided by 2 is 7.5. If I have 12 and 3, it's the same two numbers, so 7.5. 6 and 6, the numbers are the same, so if you add them, you get 12 divided by 2 is still 6. 6 and 12 is 18, divided by 2 is 9. 12 and 6 is the same two numbers, so 9. And 12 and 12 is 0. I'm sorry, 12 and 12 is 24, divided by 2 is still 12. Okay, now, what I want to do is take the average of all of these 9 sample means. So let's see, this is 9, this is 15 when I add these together. 9 and 15 is 24, that's 27. 27 and 6 is 33, plus 9 is 42, another 51, and 63 divided by 9 is 7.0. And give me a second. I kind of did that in my head, but you can use a calculator to add up all these numbers and divide by 9. Okay. Now, the median, if you recall from our first couple sessions in class, is the middle value. And if there's an even number of quantities, you might recall you just add them and divide by 2. But because x bar only had 2 values, the median in this case should be the same as the mean. So I'm just going to copy these numbers down. 3.0, 4.5, 4.5, 7.5, 7.5, 6.0, 9.0, 9.0, and 12.0. If I add these up and divide by 9 again, I get the same quantity of 7. Okay. Now I haven't discussed what am I going to do with these averages here. I'll do that in just a little bit. But for now, let's just figure out how to fill up the chart. The mode is the most occurring number. And let's see. Let's change that. I'm sorry. It shouldn't be mode. It should have been range. I apologize for that, but that should have been range. In fact, if you notice here, for my population, there's 3 numbers. So there's really no mode if nothing repeats. So there's no real value in putting something that illustrates the mode. So let's talk about range. If you remember, that's the highest minus the lowest value. So it's the range of my ordered pairs. So between 3 and 3, it would be 0, because if you subtract them, you get 0. 6 and 3 is 3. So again, it's the high minus low, if you want to put a little note here. This is high minus low. 6 minus 3 is 3. This is 9, 9, 0, 6, 6, and 0. And then if we wanted to add these numbers up and divide by 9 again, let's see what happens. This is 6 plus 9 is 15, plus 9 again is 24. 30, 36, divided by 9, the range is exactly 4. Okay. Let's do that again. I wasn't quite convinced that the range should have been 4. 3 and 3 is 6, 9 and 6 is 15, 24, 30, 36, divided by 9, yeah, that's 4. Okay. Now, as far as s squared is concerned, that's the variance of the 2 values. For one thing, let me put a little note here. This is variance. What does variance indicate? It's the difference between each value and the mean. Variance is how much the numbers are different from each other. So one shortcut is this. For numbers for which the pairs are the same, the variance has to be 0. So let's put in 0 here for for 6 and 6 here, for 12 and 12 here. The other guys will not be 0. How do we figure out the variance? There's a formula for that I can use, and it looks something like this. I'm not sure that that's visible. Let me see if I can adjust my screen a little bit. But the variance is the square of the difference of my x's, either one, x1 minus x2 or x2 minus x1 squared divided by 2. So most of these I can do in my head, I think. So for example, for this value here, 6 and 3. Okay, well if I subtract the two numbers, I get 3. Squared is 9, divided by 2 is 4.5. Now for the same number 6 and 3, it has to be 4.5 again. 12 minus 3 is 9. Squared is 81, divided by 2 is 40.5. 12 minus 3 again is 9. 81, and again it's the same two numbers, 40.5. 6 and 12. 12 minus 6 is 6. 6 squared is 36, divided by 2 is 18. And this is also 18 because the same two numbers. Now, what I want to do is add these numbers up and divide by 9. So this is 81 if you add these two. 90, 90 and 36. Let's do that. 90 and 36 is 126. If I divide that by 9, I get exactly 14. So I'll put 14 here. Okay. Now the standard deviation is S. It's the square root of the variance. So all I got to do is put the square root of each item in this column into the column to its right. I do have a calculator handy. Give me 1 second. So if I square root 0, of course I get 0. And I'm going to square root 4.5. .12, let's put. Similarly, 2.12. If I square root 40.5, let's do that here. I get 6.36. 6.36 again. Square root of 0 is 0. Square root of 18, that's about 4 point something, 4.5 maybe, square root of 18. I get 4.24. 4.24 and 0. On my calculator, I'm going to add those up and divide by 9. So let's see, times 2 plus 6.36 times 2 plus 2.12 times 2. I'm getting 38.165 divided by 9. I get 4.24. Hold on for a second. I think I made a mistake. Let me double check that. So it's 2.12 times 2 plus 6.36 times 2 plus 4.24 times 2. Divide that by 9 and I get 2.83. I apologize for the mistake there. This is 2.83. Okay. Now this next column is a little bit tricky. The PROP stands for proportion. Let me write that in more clearly. This is proportion of my odds. So if you look at the numbers 3 and 3, those are both even numbers. So if I want to know what's the proportion of odds, well, these numbers, I'm sorry, those are odd numbers, my apologies. These are two odd numbers. So all these numbers, or both these numbers are odd, which means the proportion of odd is 1.0. 3 and 6, 1 of the 2 is an odd number. 1 over 2 is 0.5. So I'm putting these as decimals. You could put percentages as well, but it works better with decimals. Between 3 and 6 is the same two numbers, so one of those is odd, so 0.5. 12 and 3, the 12 is even, the 3 is odd. This is also 0.5. This is 0.5 because the same two numbers. 6 and 6, they're both even, so none of the numbers are odd. 6 and 12, same story, none of the numbers are odd. 12 and 6, same story, none of those are odd. 12 and 12, none are odd. Now, if I add up those 9 proportions and divide by 9, let's see what I get. This is 1, 2, 3. So 3 over 9 is exactly 1/3. Okay, now, if you notice, I filled up this chart, and what I'm going to do is just kind of conclude this video because I need to have this board blank so I can write more computations. But what is of interest to us is this very last row. So again, x bar for the sample means was 7. The median was 7 as well. The range is 4. The variance is 14, and the standard deviation is 2.83. The proportion of odds, and these are averages for all 9, is 1/3. What I'm going to do is compare how these values, these averages, correspond to the population values. So let me go ahead and conclude this video, and we'll do a part 2 in just a little bit. Okay?